Okay, so I'm focusing in on this state variable Q0. And now it can go up with an arrival and it can go down when I start service and on it. And similarly, I have something similar for when I start service on a customer of type 1. And now I have implemented all of the possible state transitions I can think of, at least for that, for these two state variables. So now let's look at the number of available servers. Well, if I start service on a customer of type 0, oops, there is no S0. There's no such thing as an S0. My S is S minus 1. I lose one of these guys. And likewise here, I lose one of those. Okay, what else can cause a change in this state variable? Well, I could end service. Now here's the thing, is that I'll start with just one event. And I may have to change that. But when I finish service, I get another server back, and that's the state transition. And it doesn't matter which type I've ended service on. Now, I may have to go back and revisit this and expand it for some reason, but at this point, I have all of the state transitions that I can think of, at least, for my state variables. In other words, Q0 can go up or down, Q1 can go up or down, and S can go up or down. Okay, and then before I've written any scheduling edges, I've at least identified all of my events. Now, I may need additional events just to kind of make the scheduling happen. But this is the, before trying to finish it, I want to make sure that I have identified all of the possible state transitions, because otherwise I'm just, there are going to be things missing. All right, so again, I just sort of verify that all of the possible state transitions have occurred and that I've written them down. What's more challenging when it comes to creating the event graph models is that there's actually less structure than writing the SimKit stuff. So if I'm writing a SimKit program, I already have an event graph in hand and I'm simply translating it. Here, there's a little bit more uncertainty. Like, have I really identified all the possible state transitions? Okay, and that's more of a subjective type of thing. But again, what I've done is I've just written all of the state transitions, starting with run. And now I move on to the scheduling edges. And again, I can be informed by my experience with the multiple server queue, but I don't want to be handcuffed by it. In other words, I don't want to be in a situation where I'm just kind of blindly writing in scheduling edges because that's what I've done previously. Okay, so everyone, I want to be as mindful as possible in terms of saying, okay, this event will cause this other event to be scheduled. Okay, and when I have an arrival of a type 0 customer, then I may start service on that customer, providing there is an available server. And again, and for the assignment, I know technically we had the sort of high priority stuff. For the assignments I'm giving, you don't have to worry about the priorities. So we're not going to worry about that here. And likewise, an arrival of type 1 customer could schedule a start service if there's an available server. Now, sometimes what you might be thinking about is, well, when I have an arrival of type 0 server, I need a customer, I need to worry about I need to sort of check the other queue. Or if I have an arrival of type 1, do I have to check the other queue? And the answer is no. If a type 0 customer arrives and there's an available server, then it doesn't, then first you have to know, there can't be somebody in the other queue, because if there were, there wouldn't be an available server. Okay, so now let's look at when I schedule when I have an event that I start service on a server of type 0, I can schedule an end service with a delay of 0. And this is important here, because this is the delay for a customer of type 0. And likewise, if I end service, when I start service on a 1, I can schedule a end service with a delay of a service time of 1. Okay, so far everything has been more or less analogous to what we've had in the multiple server queue. But now we need to worry about the fact that we prefer type 0. Oops, no, I don't want to. Because when I have an end service event, okay, now what does that correspond to in the actual system? That corresponds to the fact that a server has completed service. And what do they do? Well, in the past, we've checked the queue to say if there's a customer in the queue, then we want to start service on them. But now we have two queues. We have the type 0 and the type 1, or the type 0 and the type 1. So if I say I prefer type 0, that means that if there's an available server of type 0, then I will schedule that, and I don't need to worry about what's in the other one. However, what is the other possibility? The other possibility is that there's nobody of type 0 in the queue, but there are type 1 customers. So what am I supposed to do there? I'm supposed to serve the type 1. So how can I express the fact that if there are no type 0 guys, but there is a type 1 guy, then I can start servicing that type 1 guy? And so let's express that. If type 0 is 0 and type 1 is bigger than 0, then that's the condition. So this is kind of the crux of the problem. This and this. The fact that my preference, the server's preference for type 0 customers, is expressed by the fact that I only need to check that there are type 0 customers in the queue, but the server will serve customers of type 0 if there are no type 1, if there are no type 0, but if there is a type 1. Okay, so now at this point, I've identified all the events, all the state transitions. I've identified all the scheduling edges I can think of, so I think that I'm done with the model. Okay, so let's see how I did on that. Okay, and this is the one that we wound up with. And this, I think, hopefully is the one with the exception of these high ones. I didn't put the high things in. And again, I'm not making you responsible for those. But again, the key thing here, the key element is the difference between this edge and this one. So you have to be careful, because if you, for example, if you forgot this, if you didn't put this in, then there would be a situation where you had one server. You had, in other words, if both of these are true, if there's both a 0 and a 1 available in the queue, and you only have one available server at this point, then this would schedule both a start service on a 0 guy and a start service on a 1 guy. And that, after that was done, the number of available servers would be negative. And once that happens, then all hell breaks loose, basically. Okay. So remember I mentioned adapters. Question?
Can we go back to that slide? Why not add the condition of and a server must be available, or and S must be greater than 0?
Where? Here?
On both of them.
On both of them. Great question. Can anybody answer that?
Is it because you've already established this server's greater than 0, number of servers?
Exactly. Yes. Yeah. So it wouldn't hurt anything, but it wouldn't be necessary, because we've already, remember, this is being scheduled from the end service event. And so S has just been incremented. And since S can never be negative, after the end service event has executed, S is always going to be at least 1.
That makes sense. Thanks.
Yeah. But great question. It's one that you should always be asking that. That is why, why don't I need this condition? But see, a similar thing is happening here too. Because Q0 is going to be decremented, I need to make this is going to make things really bad if Q0 happens to be 0. So a necessary condition for start service on a 0 is that Q0 be bigger than 0. That's a necessary condition. So what guarantees that? Well, here, what guarantees it is that Q0 is bigger than 0 because it's been incremented here, and S0 is bigger than 0 because of the condition. And here it's the other way around. S has been incremented, but Q0 has the condition. But those are, you should always be asking that. Okay. Now here's the problem now about how do we get this to actually work? Well, there are a couple ways, but really the one way, given that we have an arrival process will not work on this directly, because remember, an arrival process has a plain old arrival event. So an arrival event, so that's what's happening in the arrival process. But an arrival does not match arrival 0. Remember, the name of this event is arrival 0, and that's not the same as arrival. And the name of this event is arrival 1. That's not the same as plain old arrival. Okay, so how do we deal with that? Well, that's where the adapters come in. So now one way is to have two instances of an arrival process, each with their respective inter-arrival times. But in this first one, I adapt the arrival event here to the arrival 0, and that will stimulate the arrival 0 events. And here I adapt the arrival event in the arrival process to the arrival 1 event. And that in turn will trigger these. So what order will these happen in? That's all up to the event list and how these things get scheduled. But see, now, I mean, up until now, we've only had like one arrival process in our main, but here now we have two. So one of the advantages of doing this as a class is that the class arrival process, we can stamp out as many instances of it as we want. And one of the reasons why it can be very helpful to extract the arrival from the server is in a situation like this, where we don't have to add additional parameters to this model to count for the inter-arrival times. We can
on this slide, why aren't there two boxes for the two server types and another box for one server?
This one box is just is this whole thing.
Okay, all right.
This whole thing is this box right here.
Yeah, I guess where I get confused is when we did our programming on NetBeans, I thought like we would always do a listener for the arrival process class, just one, and I thought that was represented by one box.
Well, in the multiple server queue, that was correct because we only needed one. Here's a situation where we have two different arrival streams. And so we need two different arrival processes.
Oh, okay. Okay. I missed that nuance.
Yeah. So I mean, before we only needed one because that's all we had. Here we have two, and so we need two. And if we had n, we would need n. In fact, I'm not sure if it's either in this one or the next one where I actually take a look at that.
Do you, let me go back to that one again. So for the arrival process, when we're doing this, you want us to draw like you want us to draw out the arrival process in the event graph and then show this, and then below that, show the two customer type, one server graph? I'm just trying to like how to, just the mechanics.
Yeah, if I'm asking this as a problem and I say, show the listener diagram or the adapter diagram, then what I would, if you, let me get rid of this. Okay, so if this were a problem, then you would need to define the parameters, define the state variables, and then if you define this as your component, and then wrote this as the listener diagram. So if you say arrival process, I know what an arrival process is. You don't have to draw that out. And if you say that this is one of these, then you don't have to, you don't have to draw it twice.
Okay.
Okay, does that clarify it?
Yeah, I think so. So just that first PowerPoint and then this one, and that gives you everything you need from us. Okay.
Yeah, exactly. So yeah, so it's like if this is kind of the crux of it. Usually this is the essence of the modeling nugget or problem that I'm asking you to wrestle with. Yes.
So one thing that on the homework assignment that throws me off, I don't know if I've seen before, is it says the service times depend on both the customer type and server type. That is, service time should be specified as TS sub I sub J. Hopefully I said that right.
Yes.
To me, that means we need like some sort of if statement.
Well, not necessarily. Look at this situation. Here, the service times, in this case, they only depended on the customer type. But if I start service on a customer of type 0, then I know that I need to use a service time of a customer of type 0. And likewise, if I know that I'm starting service on a customer of type 1, then I use a service time of a customer of type 1. If the service time depends on, now in a situation where I have 2 types, if I have an event that says that I start service on a customer of type 0 using a server of type 0, then I know that the service time for that is going to be the service time for a customer of type 0 on a server of type 0, or T0S00. In other words, for by analogy to this situation, because I know that I'm starting service on a type 0 customer, I know that the service time has to match that. Okay, does that make sense?
I think I'm starting to see it.
Okay. Now, if I'm in a situation where I've told you in a generic way, I have a customer of type I and a server of type J, if my event knows that, then I can simply say it's the TIJ. In other words, like if we look at hopefully this would address that, because earlier there was the thing of, well, in fact, when you kind of look at this event graph, one thing that sort of comes to mind is, what's the difference between this arrival event and this arrival event? The only difference is this has 0 and this has 1. This is named 0 and this is named 1. And what's the only difference between the start service 1 and start service 0? Well, the only difference is our state transition and our scheduling. So that suggests that we can parameterize our events by adding an argument to it. In other words, if I say now, and I think people were kind of commenting on this early on, and say, well, we can look at Q as an array. And so now if I have an arrival of type I, then I can simply increment QI. So if I is 0, then I increment Q0. If I is 1, then I increment Q1. Okay, so now what I've done is I've kind of combined these 2 events into this one, but I have to put an argument there, because you need, if I say, it's not enough to just say I have an arrival, I have to say an arrival of what type. And likewise, for the start service, okay, again, I've start service 0, start service 1. What if I parameterize that and said, give me a start service with, and I'll tell you, I'll tell you when it's scheduled, which type it is, 0 or 1. So I always decrement S, but now I'll decrement Q sub I. And how do you know what I is? Remember, every event has to have that information. So I'm telling the start service event I which customer type it is by passing it in. This is crucial. So if I have an arrival of type 0, then it may schedule a start service of type 0 because it's passing 0. If I have an arrival of type 1, it will schedule a start service of type 1 passing the 1. So if I can find a way to generate all these arrivals, then I'll be good. And similarly here, if I have a start server, because I've told you what the I is, my processing time, the delay between start service and end service is TSI. So that's if I start service on 0, it would be TS0. If I start service on 1, it would be TS1. Now, end service doesn't have an argument because it doesn't have a need for one. Its state transition doesn't have an index, as I always increment the server. But what's tricky now is, you see, I have one scheduling edge back to start service and another one to start service 1, each with different conditions. And so I need to keep both of those scheduling edges in this model. And which one I have depends on what the state is. And there's no way to kind of array of, well, there is, but it's just inordinately complicated. In other words, here's where the priority kicks in. If there's somebody in the of type 0 in the queue, I want to start service on them. So how do I do that? First, I check to see whether Q0 is bigger than 0. And then here I'm passing it 0. So this is saying if there's a server of type 0 available in the queue, then I will schedule a start service I, but pass it the value 0. Or if there's no type 0 in the queue, but there is a type 1 in the queue, then I'll schedule a start service passing 1. In other words, that schedules a start service on 1. Okay, so do you see how this is the same? It's the same model as this. It just spelled out a little differently. Okay, and okay, so now okay, so I'm the final model for today is I have two types of customers, and now they have their different service requirements are kind of twofold. One, they do have different service times as we had before, but they also have different requirements on the servers. So in other words, and I'm calling them type A and B just to be different. And the main difference in addition to the service times is that a type A requires one server and a type B requires 2 servers. And the servers prefer type B. So you can imagine, a shop where, say, different items come in for maintenance or repair. And some of those I can, one guy is enough to do it. And others I need 2 guys. Okay, so that's a different situation than we've had so far. So how can we handle that? So again, as always, we start with parameters and state variables. And again, we're going to, we're not going to worry at this point about the arrivals. We'll figure that out later, but we're going to focus just on the server component of it. So the parameters and state variables should look very similar, except I'm using A and B just to emphasize that here it's going to be trickier to try to parameterize it. So a lot of times the easiest way to go forward is to not worry about arrays and just kind of do things in a brute force way. So again, we have the K servers. We have different service times for our type A and type B. we have a number of available servers, initially K, and then 2 types in the queue. Okay, so here's the event graph, and it looks kind of messy. But let's just sort of parse it out piece by piece. And always start with the run event. Okay, so okay, we can always start with the run event because we can identify our initial state variables. And so none in the queue of type A, none in the queue type B, and K available servers. Okay, no problem there. So let's look at, ignore the scheduling edges for now. And you'll see that the the events are pretty much analogous to what we did in the previous model. So almost. So an arrival of type A means we increment the number in queue of type A. An arrival of type B means we increment the number in the queue of type B. Now, when we start service on A, we take away 1 from the queue in A, and we take 1 away from the server. But here's where things are a little different. When we start service on a B, we take 1 B away from the queue, but we take 2 servers away. So we need to make sure that this event now needs to be protected by the fact that S has to be at least 2 before we schedule it. And then the end service events, again, in the end service A, now I can't, now there's a difference. There's a different state transition, whether I finish on an A or I finish on a B. So when I finish on an A, I get 1 server back, but when I finish on a B, I get 2 servers back. And that's what complicates some of the scheduling. Okay, so the state transitions, again, ignoring the scheduling edges, the state transitions are fairly straightforward, with the one little tricky thing here that for the Bs, we go up and down by 2. And we'll see how that complicates things. Okay, first, if we have an arrival of type A, then actually all we need to worry about is there at least one server? So is S bigger than 0? If so, we can start service, no problem. Okay, but if a B arrives, we need to make sure that there are at least 2 of them. And the way we do that, we could do this, or if we said S is bigger than or equal to 2, that would maybe make it clearer. You know, my mouse keeps jumping ahead. Okay, so that's one difference there. Okay, so let's look. Let's look at our starts. I don't know why my mouse keeps doing that. Okay, so starts, now let's look at the scheduling edges. So if we focus very carefully, we see that a start service on A is just going to schedule an end service. That's all. And the delay is the service time for an A. And likewise, for a start service on B, it's just going to schedule an end service on B. Okay, so with the delay of a service time for B. Okay, fairly straightforward. It's on the end services that things get tricky. So let's look at the end service on A first. So what happens, again, without kind of worrying about the eventy pieces of it, when we finish service on an A, there are two possibilities. Remember that we prefer Bs. So if we can, when we finish service on an A, if we can, we want to schedule a start service on a B. So that this is something that's a little different. Now, see, if we leave this out, then we're ignoring a possibility that we kind of switch. So we finished on an A, but if there's another guy that we can work with, and if there's a B available, then we want to switch to that. And that's what this, here, you know, because it was a little complicated, that's what this condition is. That is, if there's a B in the queue and there's at least one more. So the question before was, on the previous event graph was, don't we need to check to make sure that there's an available server? And the answer there was, well, we didn't, because we knew there was one. But here we need at least two. And just because I've increased it by one, I don't know if there's another one. But if there is another one, then I do want to schedule that. Get rid of some of these. Okay, so if there is one, then I want to schedule that. And if there isn't, then I can schedule an A. All right, so now what is the condition that I schedule an A? And this is where it's a little more complicated. Okay, first, there needs to be an available A in the queue. And it has to be the case that I can't do a B. So now here's the Boolean logic thing. In other words, it's not this condition here. And not that is essentially QB is 0 or S is only equal to 1. And we could either do that from a purely Boolean thing. Remember, when we not a compound Boolean, it inverts the two expressions and turns the end into an or we can just do it from first principles. So under what conditions would we not be able to start service on a B when we finish service on an A? Well, one would be is if there's no B work available, if there's no B waiting. So that would be one. Another would be is if there's another guy, there's no other guy to help us. So if either of these conditions is true, then we can, if either of these conditions is false, then we can't do this. In other words, if we can't serve a B when we finish on an A, then we can serve an A if there's one available. Okay. Now things are even more tricky when we have an end service on a B, because now we have two available servers. And now because we prefer B and we know that there are at least two, we can schedule a start service on a B if all we know is that there's one available. However, there are two other possibilities. So what if there are no Bs available, then, well, if there is an A available, then we can schedule a start service on it. So in other words, if there's no B and there's a there's an A available, then we can schedule a start service on that. But if there's no B, what if we finish service on a B and there are two in the queue of A, but none in the queue of B? Well, in that case, we can also schedule a second start service on A. In other words, when we finish service on B, we have we have two available servers. We can either take both of them and work on a B, but if we can't do that, then we don't want to just have them sitting around if there's work for them to do. So if there's no B and at least one A, then we can schedule one start service. And if there are no Bs and at least two in the queue for A, then we can schedule a second. So both of these scheduling edges are absolutely necessary, or else the model isn't going to work. And as before, we can, how do we drive this? Okay, so we have a start service, we have an arrival A, and that's not the same as arrival. And we have arrival B, and that's not the same as arrival, but thanks to adapters, we can drive it by adapting arrival to arrival A, and this arrival to arrival B. In other words, we have two different arrival processes for each of the type A and each of the type B. And so two different instances of the arrival process can drive this server component.
I had a question with that.
Yes.
If you make it arrival process A and arrival process B, then do you need the adapters on the listeners?
Well, do we have what is an arrival process A?
Like they'd be two separate programs, I guess.
Yeah, so I mean, in other words, could you write a program? Could you write one class that would have arrival A, arrival A's with their own thing, and then another one with arrival B, and that you absolutely could. Why don't I do that? Because I'm lazy. In other words, I have a perfectly serviceable class in the arrival process that produces a sequence of arrival events. And so, rather than writing two whole new classes that basically duplicate code that I've already written in my arrival process, but just sort of change the name, instead of that, I just changed the name using an adapter. So yes, you could do this, but that would be a whole lot more work than I'm willing to do.
Are you writing the adapter in the main class?
Yes.
Okay.
Or I mean, I'm not writing I'm instantiating the adapter.
So you would write an arrival A, so you'd write an adapter for arrival, or you put that in the server component?
No, the server, I don't put it in the server component because the server component, the idea is that the server component doesn't know where these things are coming from. There are actually a number of different ways of doing this. For example, instead of an arrival process driving this, I could have another multiple server queue driving this, and then I could adapt end service to arrival A, and that would work just as well.
I'm just trying to understand, where is the adapter? Is that its own class?
The adapter, it's a class in, well, for now, don't worry about how it's implemented.
Am I wrong assuming adapter, from what I read, adapter means the same thing as listener? Or am I missing something?
No, it's not quite the same because an adapter, this will adapt the arrival event to the arrival A event. A listener will only hear, if I was just doing a listener, which is a single connector. This would hear arrival events and say, do you have an arrival event? The problem is I don't have an arrival event. I only have arrival A and arrival B events. The listener hears everything. The adapter will only hear this and change it to this.
Oh, okay.
So they're similar, but they work differently. And the whole idea of the adapter comes from the principle of laziness. That is, given that I have a component, the arrival process, that produces a sequence of arrival events, and I want a sequence of arrival A events. So instead of writing a whole new class, which I could, but instead of that, I just say, I just want to adapt the arrival event to an arrival A event. Now, how this gets implemented is something we will, which will be forthcoming. So, you know, so for right now, don't be concerned about how this is implemented. Just understand what it is and understand the difference between a listener and an adapter. You know, they're similar, but just work differently. An adapter just works with one event and turns it into another event. A listener hears all the events.
So I had another question relating to slide 12, the previous one on there. I'm going to try to, hopefully this makes sense, but let's say that customer B could be helped by, I'm trying to make it make sense, kind of similar to like the homework. If customer, let's say how you have it, arrival B to start service B, S greater than 1. But if S was just greater than 0, arrival B could go to start service A. Under start service A, if start service A could take in customers A and B, could you put an if statement under start service A to determine if a customer A or B is currently in service at that position?
No, you cannot put if statements in state transitions.
So how would you, if they could go, I guess, similar to the homework, if there were 2 different types of servers and 2 different types of customers,
Right.
but customers can go to either server. Once they start service, how would you determine what type of customer is being served and what type of customer to take out of the queue?
Okay, well, to answer that, I'm going to ask another question. How does start service A know which customer to take out of the queue?
Because it only takes in customer A's.
Right.
Okay.
So if I had an event that said, I want to take an A out of the queue, and let's say I had a server of type C, then I would have an event that would have a state transition that would decrement QA and SC. And I would need different events to take into account all the other combinations. In other words, without parameters, see, I would just caution the terminology, because in this, there's nothing that goes into the events. These events are simply state transitions. And so there's nothing that goes into the event. The only time something goes into an event is when you pass it as an argument. So similar to this one, see, now the only thing that what goes, quote, into the event is the argument that says, in this case, which type of customer is being served. But here, there's nothing that goes into the events.
So in that one, if you had 2 different types of customers and 2 different types of servers, you would have to have 4 start services based on the different customer, if customer A, server A, customer A, server B, or customer B, server A, customer B, server B, something similar to that.
Correct, yeah.
Okay,
Just as
that-
here, we had, we had to have two different start service events because we had two different types of customers. If there are four different combinations of state transitions, then you need four different events.
okay, that makes a lot of sense. Thank you.